Hey, Math 1040 students, I wanted to make a quick video on chapter 4. I want to make it quick because if I don't, it'll take a lot longer to load and get ready for you. I have a data set that I went and gathered. I'm interested in cars right now. I'm looking at Honda Odysseys. I got 8 data points, so I have 8 rows of information. I have the number of miles that the car has been driven, so these are all used cars, and the asking price off of the website KSL. I'm pretty sure you've heard of it. Okay, so here's the scatter plot. We can see that we have a moderately strong negative linear relationship between miles driven and price of the car, with maybe an outlier right here. Not really. I mean, it's pretty. I mean, it's a moderate relationship. It's not very strong. Um, Earlier we talked about. So this is bivariate data, two variables, bivariate. We talked about correlation earlier. Let's go ahead and calculate the correlation coefficient by clicking on Menu, Statistics, Stat Calculations, and then two variable statistics. Miles is our explanatory variable because we're using the miles to explain the price, because it makes sense that the price is affected or explained by the miles and not the other way around. Okay. We got the average miles, standard deviation for miles. If we scroll down, there's the 8 data points. There's the average price and the standard deviation for price. And if we go down a little bit more, we see that we've got a correlation coefficient of negative 0.77. Right, so this shows the strength and the direction of this relationship. We can see that we got a negative direction, and the strength, like I said, is moderately strong. This is on the stronger side of moderately strong, because we got a negative 0.77, which is, it's pretty strong. If it were -1, that would be perfectly linear, right? In other words, the dots would perfectly align with trend. Okay, let's throw in a least squares regression line now. Okay, we're going to analyze this. I'm going to go to regression. We're going to go with mx plus b. Why not? Okay, we got the equation right there. We can get the equation also in this spreadsheet if we'd like to by clicking on Menu, Statistics, and go with linear regression mx plus b. The slick professors say ax plus b, but it really doesn't matter which letters you use, just as long as you know how to interpret them. So m is the slope, and b is the y-intercept. Let's maybe escape. Let's go back to the scatter plot where we can actually see it. I like pictures. Most people tend to like pictures. So this is our y-intercept. If this x value were 0, if, in other words, we had driven 0 miles, then this would, 0 times anything would become 0. And y, this is y hat, technically. This is the predicted price of a car that had been driven 0 miles, right? So you can put in any x value here and get a predicted price, a y hat. And if we put in 0, then the y-intercept is interpreted like that. If we have 0 miles driven, right, there's a context now. 0 miles has been driven, and the price of the car would be predicted to be $18,903.35. It's probably a little bit less, but that's what that would mean if we had some data points closer to 0. In this case, we don't, so we can't really interpret that too well unless we had data points closer to x equals 0. Now this slope, let's talk a little bit about the interpretation of slope. Slope is, if you'll recall, rise over run. Well, this is a negative relationship, so it is not rising, it is going down. And the run is divide by 1. Well, when we go one more value to the right, that's one more mile driven, okay? And so this represents the decrease in price in dollars for one additional mile driven, okay? So those are some things that you can think about in terms of interpreting the slope and the y-intercept, right? They have meaning now in the context of the situation with these two variables, these miles and these prices. Okay, so in other words, this car is, well, this type of car, it's a Honda Odyssey. I've got several different Honda Odyssey miles and prices, but typically, or on average, you could say that for every additional mile driven, the price decreases by about 9 cents, right? 8.7 cents, so about 9 cents. It's going down. Okay, we talked about the correlation coefficient. We described the values. If we wanted to predict prices based off of miles, we just put that value in for x. So say I wanted to find or kind of guess what the price of a car that had been driven 100,000 miles would be, right? Well, I can just take this equation. I'm going to kind of just try and memorize it here a little bit and use this. We got negative 0.087. Oh, what's going on here? 18. Start over. 18903.36. Okay. Start 336. So that was the y-intercept. I'm going to go minus 0.087. And for a 100,000 mile car, I put in 100,000 miles. Let me make sure I have the right number of zeros. Yes, I do. Okay. End the parentheses. I didn't want that there. And so it predicts that the price of the car that had been driven 100,000 miles would be $10,203.36. Okay, so that's how you can use the LSRL for prediction purposes. Okay. All right. How good are our predictions? This is I'm kind of moving on to 4.3. We talk about the coefficient of determination, which helps us assess how reliable the line of best fit, or the LSRL, will be. This is a regression line, the least squares regression line, and I talked to you a little bit about why we call it least squares. Maybe I'll just review that briefly. We talked about residuals earlier, and residual is the length, or the distance from the observed value from the predicted value. The predicted value is along the line. That's our y hat values. And we see that that's that length right here. But the way we get this line is we actually square those residuals. We create squares out of them, and we add them all up, and we use a mathematical process that reduces or creates the least area of the squares. Okay, so these least squares. And that's how we get the line. Okay, I'm not going to talk to you about the process, but that's how it is, how it happens. That's the general idea. One way we can assess how good our line is, I'm going to just read it. I'm going to hide that. I'm going to talk about the r squared value. Okay, I don't know if it has it over here. Let me show you how to get it. Okay. The r squared value is this is on the notes for 4.3. This is the proportion of the variation that is explained the proportion of the variation in our y variable price. I'll go back here. The proportion of the variation that is explained when we use the LSRL, right? Some of the variation is really small, like this one's really close to the line. Some of it's really big, right? Because this one's further to the line. So this is less explained by this this trend line. The r squared value basically is the r value, the correlation coefficient, squared. And we usually talk about it in terms of a percentage. So what we do is we take this value and we square that. Okay, so negative 0.7709 squared, negative 0.7709, and we want to that puppy. So 0.5942. So we turn it into a percentage, and we say that 59.4% of the variation in price is explained is explained by the least squares regression line with miles, right? If we did not have miles to use as a predictor for price, then we would probably just go with the average price, okay? And if we use miles, it actually helps us get a little bit closer to the actual value. So if we square the r value, we get that proportion of the variation that miles explains in price. Okay. So this was none of the examples that you will have seen in 4.3 or 4.2, but I think that it's an interesting one because hey, we all drive cars, and I'm actually interested in buying a Honda Odyssey, and so I was kind of just a little bit curious. Anyway, moving on, I want to talk about 4.4, where we talk about two-way tables. So we're still examining two variable data, but now we're talking about two variable data that is in categories. So this is actually some data that I got from the exercises, or from the I think it's from page 12. Let me make this a little bit easier to see. Okay, so we got this survey of a bunch of people, and they asked them whether or not they were in good health or poor health, or maybe they assessed that as a doctor, and then they asked them whether or not they were happy, or I guess they had these three options: not too happy, pretty happy, and very happy. Okay, and we got the numbers here. If we want to know totals, we can just do some totaling. If you know anything about Excel, you can total up columns like so, or excuse me, rows, right? So there's 73 people that said that they were not too happy in total. I want that to be the same size. So I want them all to be the same size. There we go. So 73 total, and I want to drag this over like so. And there's 250 who said they were pretty happy. So that's these two added together. And 144 is these two added together. They said they were very happy. Okay. And I can also add these up in the columns. Okay, so 126 said they were in poor health, and then the total for people who had good health was 341. And if I total that row, then that's the total number of people that took the survey. Okay, and then these three should also total to the 467. Okay, so this is two variable data still, but now we're in categories. Okay, and we're using counts or frequencies to kind of examine them using it's math class, right? We like numbers. Okay, so what I'm going to do, well, actually, first off, these total columns here, this one and this one here, these are the I want to. These are what we call the marginals because they're on the margins. Okay, so these are marginal frequencies or marginal counts. Basically, it's the total column. Okay, and one thing that we often do with two variable data is we're interested in whether or not there's a correlation or an association. Right? We talked about association earlier, being positive or negative. Seeing if knowing something about one variable or one categorical variable will give us some clue as to what will happen in the other categorical variable. Okay, and I'm going to do that by showing you. I'm going to just copy this here. I'm going to delete that out. All those marginals will now go to 0. We're going to look at a conditional distribution. Okay, so on the condition of the health status, what proportion of people said that they were not too happy? So we know that there was 126 people who said that they were in poor health, and 43 of them said that they were not too happy. So this proportion would be 43 divided by 126. Okay, so percentage-wise, that's 34%, and we can do the same thing for this group right here, right? 61 divided by 126, and 22. Excuse me, I put the equal sign. 22 divided by 126. Okay, and so we got the conditional distribution, or excuse me, the proportion of people who said the different status for happiness based off or conditioned on the health status. Okay, we can do a similar thing here for the good health. There was 30 out of 341 that said they were not too happy of the good health people. Okay? And then, so that's, as a percentage, that's 8%. I can do the, and I can do the same thing for pretty happy. There was 189 out of 341, and 122 divided by 341. Okay. Notice how both of these add up to 1 because 100% of the people are totaled up here. Okay. So yeah, I can take a look at these percentages. Let me actually convert these to percentage. Excel's nice that way. There we go. That looks a ton better. Okay. So there's that. 34% of people said they were not too happy when they were in poor health. They were pretty happy when they were in poor health, but only 17% said they were very happy in poor health, as opposed to 36% of people who said they were very happy with good health, right? So you got a lot more people saying that they're probably a little bit happier when they're in good health. That should make some sense to us, okay? We can create a segmented bar chart on this to really see the association. Okay. Normally I would show you how to do this, but I'm trying to make the video quick. And Excel has this nice insert chart feature that I'm just going to use and then kind of explain. Right. So I'm going to give this chart a title. We've got health and let's use the shorter one, and happiness survey. Okay. We can see this one. This one's pretty good. I prefer to. I think I'm going to prefer to just have it. I'm going to switch these. So instead of having the happiness category here, I'm going to have it go like this. Okay, because this is how I have the data here anyway. And let's show the percentages. Let's see. I like to have the 100% bar. There we go. There we go. This is good. This is good. Here we can definitely see there's an association between health and happiness. Okay, so of the people who said they were in good health, there was a lot larger percentage, almost double, for the poor health people who said that they were very happy. Okay, so this visualization, because we can see that these bars are uneven, or that these segments are uneven, then that's very indicative of an association between these two variables, health and happiness. Notice that the y-axis goes up to 100%, right? So each bar goes up to 100%. Of those people who have poor health, 17% said they were very happy, 48% said they were pretty happy, and 34% said that they were not too happy, which kind of makes sense because they're in poor health. They're probably suffering. Those people who are in good health, only 9% said that they were not too happy. They're probably watching the news. And people who said they were pretty happy, a lot larger percentage. And then the very happy people is 36%. You can definitely see there's an association between those two. Okay, so really quick, these are called two-way tables or contingency tables. And we're going to use these a little bit more in chapter 5, talking about probability. This one is based off of counts or frequency, and this one's based off of relative frequency. Okay, and then these two distributions here are conditional distributions, right? So it's the proportion of people who said that, who answered different according to the different happiness levels based off of their health, right, or conditioned on this value, poor health or good health. Okay, that's that. Hopefully this video was helpful to you. I'm going to try and make a video for chapter 5, and I'm hoping to make it short as well. I'm going to help you out as much as I can when I get back. Good luck. Email me with questions, like several of you already have, so that's good. But more of you may need to ask me questions, especially since I'm not there. Anyway, take care.